We're back here at reference, our favorite place to be. And with this particular reference, we have those directional plumes that we're trying to get. And where do they come from? Well, they come from the collision. This guy's probably going through a window. That guy's probably going from the top that disintegrated or something. And this guy is probably coming from the garage. Or however that building is set up. But it's taking on the shape of the building, or I should say the building's holding in a lot of that energy, and it's creating these shapes right here. So how can we make something like this in Houdini? Well, here we have a European bathing suit, or in America, a Speedo. And this particular Speedo is a magical Speedo because what we're going to do is make an invisible collision, not in the shape of a Speedo, but in the shape of a sphere. And we're going to have some holes in that collision so that these puffs can go out and give us a bit more direction to our explosion. And so with this collision mesh right here, all we need to do is generate this for maybe 2 seconds, something really, really fast, just to dictate the initial movement of that velocity. And that's going to do a really great job of breaking up this simulation. We're back at our network, and I want to take the geometry right before it turns into volumes. So I'll take this guy and use a bound sop right here and set this to a sphere. Let's also convert this to polygons. So convert, divisions per span, and I'll say 50 for U. Let's also set down a transform. We'll want to move this around eventually. And we'll also make a clip so that we can get rid of the bottom section. Bring that up right about there. Okay, cool. Let's now go down to our cache and see what's happening here. Again, we only want this to last for maybe a couple of frames, but we need the sizing to be pretty spot on. So there's frame 31. It looks like we expand outwards pretty quickly. Let's go to our transform up here. Give ourselves a little bit more. Also center our pivots, so $CEX. Oops, there we go. $CEY and $CEZ. Okay. We'll scale this up a tad bit, bring it over in Z as well, so that we end up with something maybe right around here for right now. We'll probably change that later, so just a rough guesstimate is just fine. Okay, and that gives us the start to our sphere. Now, how are we going to put holes in the sphere so that the fast-moving plumes can go out and then everything else gets trapped inside? Well, it makes sense to go down to our velocity. We have particles, right, that represent where things are going, and these particles on the exterior here are going to represent the areas with the most velocity. And so if we can just take the particles on the outside along here, then that should be good for dictating where those holes go. I've found that it works best to take the geometry after we group the points down here that are underground. I don't want these guys actually making holes in that sphere. And so marking them is really good, but I do like having them there when we define the shrink wrap node around this whole thing. So we'll take a null. I've called this our out colliz sphere particles. We'll take an object merge, bring that over. So now we have these particles up here, and we're going to use the shrink wrap and shrink in a little bit like so. We'll then use a group, set this to points, and we'll say this is our shrink wrap blast right there. Keep in bounding regions. There's our shrink wrap. There's the original particles. And that should be pretty good as soon as we select the bounding object. Okay, so let's take this shrink wrap further in like that. And there we go. There's going to be 2 blasts now. So one blast for the shrink wrap blast and another one for the particles that were tagged underground. So that's going to be our blast points right there. So all of these guys are going to dictate where the holes go. If we use this in combination with the ray sop, that will stick these points along the surface of our original sphere. So here is our collision primitives, here are the points, and then we can set this to minimum distance, and that'll attach them like so. Once we have that, we can then use a copy to points and copy over some spheres, which will allow us to basically create little cutters for the original sphere. So create a sphere right here. Whoops, there we go. And we can turn this into polygons. I've personally found that it's easiest to turn this into a volume. So VDB from polygons. And then we can use a group sop to group the original points of our sphere. So that's going to be this guy with this volume. So we'll say cutter sphere blast right there, points, and we can just select the bounding volume. All right, cool. Now let's just blast out where those points landed. And now we end up with this. Let's also set down a clean sop, and we can check on manifold only topology, which basically says delete any poly islands which have 50 or less polygons. So that got rid of all the little islands that might have existed. Once we have that, we can then use the thicken. So labs thicken, and this will give us the main shape for our cutter. I found that going in probably about there is going to give you good results. You don't want to choke on it too much, but you also don't want to have this be too thin, because then the solver has a hard time finding that collision. Let's also uncheck dissolve the middle edge and set normals so that everything has normals for the volume collisions. Now, as I mentioned before, we want this to only last a couple of frames. So let's go ahead and create a switch, plug that in, and a null. What we'll say is to use this null if the frame is greater than 32. Cool. That gets brought in with our original ground terrain over here. Those two come together to equal our collision. On this VDB from polygons, do be sure that the point normal is actually what's happening, because by default this is vertices, and we need to be sure that if we have a point attribute over here, that we also have a point attribute over here and right here. So that's collision vel. Also, fill interior, if I haven't said that yet. This is very, very, very important, because if you do not fill the interior, your collisions may not work well. So check that on. At 0.2, we have about 1,000,000.3 voxels. If this was 0.1, we'd have nearly 10 million. So 10 million's a lot, and we can pretty much safely say that we have a lot of voxels anyway, because this is a big area, but 0.2 is much more reasonable at, again, 1.3 million. Let's cache that out and see what happens. And after adding that collision, we end up with this, which I think adds a lot of detail. What's nice about this plume is that we have multiple layers. So we have a plume up here, we have this guy over here, that's shadowing something behind that guy. What that does is it makes it feel more complex, more interesting, and it also adds more depth. So it feels like the explosion goes back further because we have these visual layers of plumes. So that's really cool. Now, one bit of critique I do have with what we currently see is this does take on the shape quite a bit for about 2 frames right here. So there's a couple of things. We might want to consider making the sphere last about 1 frame less. We do lose that separation, or that same degree of separation in the process. but that might be a good call to do that. Also, we can deform that collision so it's not this perfect sphere shape, and we can kind of make it blend in or seem like it belongs with the other plumes right here. This is a pretty unrealistic, kind of ugly shape, honestly, but what it gives us right here is pretty awesome. And it happens so quickly that, well, you can notice it now that I've pointed this out, but you know, with a couple of tweaks, maybe a little bit of mountain sop, maybe even deform that collider a little bit over time, you can cover that up while still giving the benefits of those layers of shapes that we see right here. So anyway, I'm not going to do that in this particular example, just because I think you guys get the idea at this point. The idea is that we can have those colliders dictate the shape even more beyond velocity, and that's a really cool way of adding in this extra detail right here. So in the next video, let's move on to a different topic. Like I said before, you can improve this collider here by adding some mountain sop or deformation or perfecting the timing. I'll probably go back and do that myself, honestly, but you know, it's just a matter of doing a mountain sop and timing this a little bit differently. So in the next video, like I said, we'll move on to something else.